These estimating guys, because we're going to do take off for the project, and I want to make sure that you understand it fully. So go follow with me with chapter 3, please. If you grab chapter 3, have it handy. I'm going to highlight a few things as we go through in that chapter. Labor unit. So understanding, here's a few things that we need to understand about labor unit. Objective, what a labor unit is and why we use a labor unit. Hopefully by the end of that you understand what is a labor unit and why do we use it. Why do we use it? What's included and what's not included in the labor unit. As I said, in a nutshell, a labor unit is assigning an hour labor into an piece of equipment. To install that receptacle in the wall, I need 30.3 of an hour to install that receptacle. So that's called a labor unit. The second thing is why standard labor units must be raised or lowered according to specific conditions. If you're working on a specific condition, guys, do you think installing a receptacle here at Dunwoody is the same as installing a receptacle in the Pentagon, or installing a receptacle somewhere else in the 15th floor in downtown Minneapolis, big building, riser there? There's a lot of travel, a lot of access, so you have to raise or lower your labor unit. Okay, which labor unit manual you should use? We're going to talk about labor unit manuals, guys. We do have the NECA 2011-2012 labor unit manual. If you have not downloaded it, guys, please make sure. I'll walk you through that manual that we have. And also we have a labor unit that my folks have put together at the end, has a labor unit that lists all the material. Way at the end of your book, you have a labor unit manual. So we'll talk about this one in a second.
Where do we get the manual?
You have to. You don't have it. Jackson, do you have the CD?
Oh,
Jackson will get you the CD.
okay.
Why don't we care about competitors' labor unit? Do you care? This is an argument. Do I care about the other competitors' labor unit, guys? Do I care about, like, we have a Parson Hunt Electric. The question is, do I care about what's the labor unit that Parson give for this fixture versus Hunt versus Elliott versus CA Electric? That's the question I'm going to be answering. And how to develop your own labor unit. Ultimately, Rob, my friend, if you're a project manager, you want to use your own labor unit. A lot of here in Minneapolis, guys, or in the States, there are two sets of labor units. One set is NECA. I'm going to show you the NECA labor units that a lot of people use as a platform and they modify for their own projects. And the other one, basically NECA, you use it as a platform. The other one is other companies develop their own labor units, and they add a price to it. But the most common one is among, at least in our state here, is probably the union shops is the NECA ones. How to adjust labor units to accommodate for variable conditions. If you have half an hour to install these fixtures, how do you adjust it if this was a hazardous class 1 div 1 location? So a couple of things to answer. So these are a few things, guys, that we need to do. Okay, so I'm going to go ahead and with this rationale, and then I think I agree with it. Estimating, guys, is a science as well as an art. Why science? Because it doesn't take a smart person to go count all these fixtures, one of them, and assign a 0.5 of an hour for each one of them, right? This is where the science is. The science is we assign a labor unit in an hour to a fixture. So all what I have to do now is count all my fixtures, assign a labor unit in an hour for them, and you're done. Isn't that science, right? Count, assign. Where do you get that labor unit? From the manuals. So if you have we're going to see, for example, if I have an AC cable, AC 14.2, I'm going to assign a labor unit of 9.6 for every 1,000 feet of it. And I'm looking at the manual that I have in the book. That's already given, done. Now, what's the art about it? The art about it is, guys, you need to be able to adjust that labor unit up or down based on the condition. And that's where experience becomes a big deal. You need to be able to, okay, 9.6 for every 1,000 feet of this MC cable 14.3, 14.2, okay? Now, what happens if I want to, you can install MC cable in a house, you can install MC cable in the 15th floor, in any building. So what type of condition am I installing the MC cable under, it's going to affect the way the MC cable, the labor unit assigned to this cable. So you have to adjust it, and that's a rationale. Okay, now down into what is a labor unit. Really, that's the question. This is probably one of the most important things. What is a labor unit? It's the approximate time required to install an electrical product or component. How long will it take you to install electrical component or device? This is it. And guaranteed that will be on the test. What is a labor unit? How long will it take you to install an electrical equipment or component? Labor unit. But who are you, Nick? We're going to define the you, right? It's not you. Your speed and knowledge is completely different than Ashley's speed and knowledge, right? So I have to assign the labor unit that you have in all these manuals are based on a you that has to be defined. Who is the you, right? We know assigning a labor to an equipment is easy, but who is the you? Look at the definition of the you. This is probably one of the most important ones, guys, if you want to pay attention. Here's the assumptions about the you. Assumption number one, that you're highly trained. If you're not highly trained, that labor unit does not apply to you because it take you longer. If you're not highly trained, you do mistakes, it take you longer. Take this. And you're skilled. You know what you're doing. Highly trained, skilled. You don't do mistakes with necessary code. And skilled, you know how to terminate wires on terminals and know the code and so forth. The other one is motivated. You don't hit the guts of your of the company that you work for. You have some type of motivation, and that goes up and down. And we talked, guys, Chris, we talked about motivating people. The most important thing about motivating people in my book is respect is number one, and incentives. To motivate people, you have to respect them, respect their knowledge. Don't treat them like jerks and like slaves. Number one, respect them, and number two, you have to respect them, and you have to give them incentives. You have to give people incentives to work for you. Okay, motivated electricians. So you have to be an electrician. So that's it. Trained, skilled, motivated electricians. And so that's just about the person. And the task is under standard installation. The task that we're doing is under standard condition. No hazardous location. We're not working 20 below in Minnesota outdoor. That's not standard condition. Standard condition, heated and cooled places, right? Not too hot, not too cold, not too high, not too low. No confined spaces. Standard conditions. And we're using proper tools. The worst thing that could happen to you is you're going to be installing a bunch of fixture at 25 foot and you don't have a lift. You don't have the standard tools. You don't have the standard tools for the job. Every job has its own standard tools. I cannot tell my friend, if you want to be a project manager, this is one of the single most important things. The amount of time that assigned to an equipment, that time is based on a highly skilled, highly trained, skilled, motivated electrician that's working under standard condition with the proper tools. Condition, proper tools, and the skills and the motivation and the training. Any question guys about this? So we know what the labor unit is, right? Assigning a labor hour to an equipment based on who's going to be doing it, this electrician. Any question guys about this? Any question? Okay, so that's your labor unit. Labor unit are expressed in, we express the labor unit in the following, each. So installing every generator, mounting that generator will take 18 hours. Mounting that 2x4 fixture will take me 0.5 of an hour. Oh, by the way, we don't use minutes. We always use hours and fractions of an hour, decimals of an hour. So E stands for each. So every time you see E stands for each. Every time you see C, what does C stand for? Hundreds. So if I say 10 hours per C, means 10 hours for 100. So if I have 10 of them, you multiply 10 by 10, divide by 100. Very important, guys. Very important. If you take M stand for 1,000, take this. I have 130. I have receptacles. I have 130 receptacles. Each receptacles to install it, I need 0.2 of an hour. 0.2 of an hour. Or let's put it this way. Let's say to install it, I need 1 hour for every 100 of them, for every C. 1 hour for every C. 1 hour for every 100 of them. Okay, so what do? Here's 1 hour, and then you're going to divide this by what? By 100, because I need 1 hour for every C receptacle. 1 hour for every C receptacle means 100 for every 100 receptacle. I need 1 hour, and that's very short amount of time. So what do you do when you cache these hours? You multiply them, and that will get you 13 hours for all these, right? Did they do the math? Or 1.3.
Yeah, what's the scribble there? 1.5.
What's the what?
130 times what?
Okay, let's do the example one more time. Here. Okay. Let's take, here's a receptacle. I have 130 of them. Cool. 130 receptacles. The second thing is the labor unit that I'm given as, let's just use a realistic labor unit. Let's say 10 hours, and the unit for the hours is a C. So means 10 hours for every 100 of them when I install. Cool? 10 hours for every 100. Now when I do the math, when I'm going to do the math, let me use a grid. So take how many hours will take you to install the 130 receptacles. That's what I'm trying to do. So we take the 130, multiply by 10 hours, and what do you do next? Divide by 100. Why 100? Because that 100 is coming from the C. And that will get you 0, 0, 0, 0, right? Give you 13 hours. So what I'm showing here, to install 130 receptacles based on this labor unit, I need 13 hours. Does that make sense, guys? They give it to you either each, or 100, or 1,000. If this was 1,000, take this. Let's change this one. Can we change that one, guys, into 1,000 M? Suppose that this was 1,000, right? Look what is going to happen. If that was 1,000, you take 130 multiplied by 10 divided by M is 1,000. You divide this by 1,000. 0, 0, 0, 0, and that will get you 1.3 hours. If the unit was the labor unit was in 1,000 for M, you get a 1.3 versus 13 hours. If it was each, look what happened if that was an each. If this was an each, take this, do it for an each. 130 times 10 hours divided by each is 1. 1 divided by 1, and that will get you 1,300 hours. It's a lot. Everybody knows how to use these hundreds and cache them when you extend them. That's how they do it. They assign a labor to a unit, multiply it, but that labor unit can be given in a C, in an each, a C, or an M. When you read, guys, through these manuals, you're going to find an M next to it. M every 1,000, especially for cables. Like, for example, here I have AC cable 14.2. I need 9.6 hours for every M. So you measure the cable, you multiply by 9.6 if it's an MC 14.2, divided by 1,000, and that will get you how long will it take you to install that section of the cable. Based on skilled, qualified, motivated electricians working under normal condition with the proper tools. Nick, my friend, does it make sense? Sorry for my handwriting. If you can write worse than me, probably you'll be a doctor. Is that what they do? Doctors have I think they write bad just because they don't want you to read it most of the time. Any question, guys, about this? So labor units are given in either each, 1,000, or 100. Okay, and oh, by the way, don't use minutes. The worst thing that could happen to you when you do estimating is 15 minutes. How do you change a 15 minutes to an hour? Divide the 50 by 60. 15 minutes is a quarter, right? A quarter, that will give you 0.25 of an hour. But we don't talk minutes when we do estimation, labor units. No minute talk. So you need 15 minutes, you need a quarter of an hour. You need 0.25 of an hour. Okay, so that's how we express the labor unit. Work experience. When you electrical work speed is very important. When you estimate electrical work, I think we talked about this one, guys. Most of electricians like Ashley and her brother, when you guys do work, you estimate it based on what you guys are going to be doing it, right? Based on how long they think it would take them to do the job, how long it will take you to do the job. But when you become a project manager and estimator, and especially if you're an electrician, you've been an electrician, you're going to estimate it based on, start with you, but you have to have a factor that other people are not as motivated as you are as an owner of a company. So not gonna, no matter how much you motivate them, they might not work as hard and produce as much for you, right? The human being nature. I'm willing to work very hard if the outcome is for me at the end of the day. But if I'm working for you, I will follow every OSHA's rule and every on the book. If I have how many minutes you have, and smoking breaks and drinking breaks or whatever, I'll take advantage of all these. If I'm working for myself, I'll skip my lunch that day, and I work for 8 hours straight so I can go home early and I can get more money. Some people will do that. So be very, very important is estimate it based on you, but take into consideration that other people might not be as motivated. Who cares? Then you might have to be disappointed when you estimate this one, it will take you half an hour to install it, me, because I'm working for my company. But if I hire Phil to do it, it might take him, instead of 0.5 of an hour, it might take him 0.4 of an hour. That's okay. You can understand that. Okay, there are other factors that might not have taken into consideration. A couple of these factors that work into consideration: supervision. If you're working for yourself, Nick, do you need supervision? Do you need somebody to supervise you? If it's your own job, no, for most of the part, and other than your wife or your girlfriend. So supervision, when somebody's working for you, you need to pay attention to is a supervised job layout. Ashley is working, she and her brother working on a job. If you walk 6 electricians walking there and the job is not laid out, well, guess what? You're holding 6 electricians. They're sitting there waiting, not doing any work, to wait until the job is being laid out. Who's going to be laying out? How fast? Is the job laid out right? All these will affect it. Tool management, bringing the tools to the job, handling the tools. Half of the battle is having the right tool to do the right job most of the time. All these guys will affect the labor unit, your labor unit, handling of the material, non-productive time. How about bar fights? It's a weekend, Monday morning. We're going to talk about Halloween, or we're going to talk about, especially young fellas, about bar fighting, drinking, and girlfriends and all this good stuff. You have to have some account for some non-productive time. We're human beings. We like to visit, and that's why we have horse whipping, right? Any job condition, you have to pay attention to a lot of job condition, guys, for your labor unit too. Okay, how labor units are used. A couple of things about using labor units. Okay, labor units. The job must determine the material. So you take the material, you multiply by the labor units, like we did for the example. So we gave an example of receptacles. How many of them multiplied by the labor unit, divide by that unit for the labor unit? Is it a C or E or each labor unit? What's included in the labor unit? This is wake up. What is included in the labor unit? Right? We know the labor unit is assigned to skilled people, motivated, hardworking. But what's included in them? The labor unit include the following 6 major things. And feel free to disagree or agree with it. 6 major things. Take this. The first thing is installation. Take this. If I have, let's just say, I have let's say I have $100. I have a job. I have a switch gear, and a switch gear needs 100 hours to install. And the unit for this switch gear is E. The unit is E for every one of them, each. Cool? A switch gear to install, mount it, orient it, put it in $100. Okay? Out of the 100 hours to install that thing, how many hours do I need? 50 hours is just to install it. Cool? Let's keep going. To do the work itself. 15% is to do what? Another 15 hours to do the layout, do the measurement. When you have a switch gear, you have to maintain clearance in front of the switch gear. You're going to orient, am I going to put the switch gear on this side, the other side, laying out the job and measuring the clearances, make sure to meet the code. That's another 15 hours, right? from $100. Take the second one, material handling and cleanup. You need to grab the equipment and the material and handle them and put them there and clean behind you. That's 10 hours. Well, that's a lot in the example that we gave, but let's just say 10 hours just to do the cleanup after all the stuff that you did, based on the example that we have, which is 100 hours for switch gear. Cool, 10%. The non-productive time, 5 hours, based on the example. 5 hours non-productive time. That's where we set Halloween night and how did you guys do? How's your wife doing? And how are your kids? And we're a human being. Oh, Vikings are playing, right? There's a lot of talk about we're a human being. You cannot treat us as machines. You have to take this into consideration that we will interact with each other and we will. You have to use the word bullshit, right? That's part of a human being nature. As a good project manager, you have to account for this one in the labor unit. So 5% of every 1 hour is assigned, 5% of it is assigned for non-productive time, just scratching your head and moving around. We're a human being. The other one, supervision, 10% is assigned to supervise the work. 10% is if you are assigning a labor, you need 10% of that hour to supervise other people who are working with you, right? If you're working in a team, somebody has to do some type of supervision for these hours. And the last thing, guys, 10% for tool handling. Somebody has to go all the way to the truck, haul them all the way up and bring it back. That will get you, based on the example that we have, 10 hours. Any question, guys, about these 6 things that are part? Feel free to agree or disagree, based on Mr. Holtz at least.
So
These,
this is Mr. Holt's opinion.
yes.
No.
No. There is not based on statistics that I know of. You can add that non-productive time. If I'm working for myself, supervision, look at this, how it works. If I'm working for myself, do I need that 10% supervision? The money is coming to my bank account. So you can drop that one. Look at that one here. How about non-productive time? I might not bullshit a whole lot because I want the money to go. You can drop that one. Material handling, you have to clean up. There's nothing you can do about it. Tool handling, there's nothing you can do about it. But here's 5 and 15% if you're doing the work for yourself. These 15, they're not going away. These 15% will be rolling into less time that you need to install the equipment. But if you're doing a hospital, guys, a sport arena, teams, and all this good stuff, you have to take this into consideration. Yes, again, it's an opinion. The percentage, is it 50 or 49, 45? Yeah. For the most part, it makes sense. Plus or minus, I would say 2-3% up or down. Any question, guys, about what makes a labor unit? What does the labor unit mean? If you want to be a project manager and estimator, these information as must know, guys. After that, you can build on it with your career, and you look at it one day and you start laughing because we do it differently. But at least the brain of thought, Chris, just the brain of thought.
Now, the reason why I asked is that, for example, if these tables that we're privy to are based from this type of structure, and you want to toggle on some chart that says, hey, I'm doing it with management rather than labor, you might very well be able to
adjust it.
Click an item and drop those 2 items. If this is true to how the Nika table
as true as it could be. Close in terms of slicing the labor unit. Now, labor unit does not include, this is very important, what's not included in the labor unit. Look at this. The labor unit does not include, for the most part, again, these are also an opinion, does not include cutting holes or opening big 4-inch hole in this wall to move my conduit. That takes a lot of time, right? Depending on what type, block, concrete, reinforced concrete. So that's not included in the labor units. We have to assign it differently. Excavation, drilling, and blasting of things. That's not included. And heavy equipment operators time. Heavy equipment, if you have heavy equipment that you need to operate, that's not included in the labor unit. Hoisting above 3 floors. You need to lift above 3 floors. That's not included. Even if you're higher than 3 floors, you have to readjust. What does it mean it's not included? It means you have to readjust your labor. So if I want to install this fixture higher than 3 stories, then I might, if it takes me 0.5 an hour, I might add another 0.1. It becomes 0.6. Adjust it, up it. Doesn't mean you're gonna maintenance of temporary equipment. If you have to do some maintenance on that one, and these are you can add painting of conduits. If you have to paint conduits, we care. Most of the time, you put the conduit moving. What if you paint them to identify them based on emergency system, legally required standby system, normal system, and so forth. Somebody has to paint them unless you buy them painted. Testing or welding, if you have to do some welding and testing, not included. So these are a few things, guys, not included. A few things that's not included. And again, it's little list. Other things could be not included too. Any question, guys? Not included means at the end, if these exist in your building, you might have to up your labor unit. And that's okay, no problem. I might have to up my labor unit. I'm going to finish this one. I'll give you guys a quick break here. Unusual task. So Zach, my friend, you are faced with an unusual task that you have never done before. What are you supposed to do? You can sit, drink, go to the bar and cry. That's one option always, you know. Or you can, based on rationale that they have, determine the task that you have absolutely no idea how to do it. The idea here is to break it down into many, and this is opinion again. Take a big task, break it down into a smaller tasks, individual labor, and assign a labor to these smaller tasks, and adding them all up basically. And at the end, that will you can get as close to the truth as you can. And so breaking it down into little, assign, try to labor unit for each segment, and then compare them. And if all else fails, what do you need to do? That's why they pay you the big bucks when you become a project manager. Reasonable guess. When we invite guys, Parson Electric, to come and talk about estimating, they have wild guess and scientific wild guess. And they have use other adjectives I can't use. There's wild guess and scientific wild guess. Wild guess is just, I have a bus duct. How long will it take me per foot to install this bus duct? 5 hours. Wild guess. Okay, scientific wild guess is you envision the bus duct and compare it to a rigid conduit, right? The rigid conduit takes me per foot, say, 2 hours to install per foot, the conduit. Now, if you compare the bus duct to the conduit, it's based on the analysis that you do in your mind and knowing how the material is, it's probably twice as hard to do it, and then it will be 20 for the bus duct. And I'm throwing all these numbers. So that's what a scientific, you have to know the material and compare it to each other. So that's basically what a wild guess is. Hopefully that wild guesses, guys, and reasonable guess is only 5% of your labor. Okay, let me give you guys 5 minutes break and we'll continue. Resume here. Okay, labor units manual, which should you use? You guys are looking at the end of this book. There is a labor unit, have 1,000, I believe, 1,000 component in it. A component could be a receptacle. All the way at the end, if you look at it, guys, 1,000 of them. Or we have a Nika one here that has thousands. I'll show you, I'll walk you through the Nika manual that we have. So what is a labor unit manual, guys? A list of a lot of equipment assigned a labor unit. That's it. You're going to see them in a second here. Which labor unit should you use? A lot of people, guys, if you're a union shop right now, they use Nika and modified. The best labor unit that you can use, the best labor unit that you can use is your own. So what a lot of people, guys, is you take these labor units, you adjust them to your own company based on the productivity, the supervision, and the management skills that you have at your company. Your units are compared to others. The argument here, guys, Elliot, I don't care about the labor units that they use at Hunt Electric because it's not mine, it's not my labor. There's one little problem with this argument, guys, especially in Minnesota, because we use the same pool of electricians in Minnesota if you're a union shop. And the same, so the electricians who are 292 electricians can be working for Elliott Contractors 1 month, and another month can be working for hunt and so forth, because we're using a pool of labor if you're a union shop. So that probably doesn't apply. Supposed to be if you're a 292 or 110 electrician, you're highly skilled, motivated, blah blah blah. All these electrician, rightfully so. And if I grab him and put him in Hunt Electric or Carson, it should function the same way. So it's nice to know it, but keep in mind, guys, the labor units of your competitors are not yours, because of management and supervision is different from one company to another. If you ask my opinion, really, I would love to see what other companies are doing, are charging, so I can gauge myself, benchmark myself. Doesn't mean you can copycat what they're doing, because it's not going to work. It might not work for you. A couple of things that can affect the labor unit that he uses: computers and using technology and so forth. One factor, labor, the productivity, impact labor productivity, material and tools that you have, supervision, how motivated your people are. So these are a few things that you should keep in mind compared about your labor units. Knowing your competitor does not help you, because basically it's not yours. They are not yours. If you know how the labor unit they assigned for an equipment is not yours. How to develop your labor unit. The ultimate solution, Elliott Contractors, to have their own labor unit based on skilled, motivated electricians, that assuming you hire the electricians and you manage them with most of the time, and they're your full-time employees, guys. Now, most of the electricians, don't hire them. They're, for our shops, they work for the hall at your company. So the key point is, must information about the past labor performance of similar jobs. The best labor unit that you can perform is your own. So if you have your own electrician, all of you guys are electrician working for me, and we did 6 jobs, and I kept a track of the actual hours that I spend on every single and the whole job. After a while, I can start developing a labor unit value, right, for each and every one of components. So history, analyzing the history, track job hours and compare them against the job's budget. After a while, you start developing your own, basically your own labor units. And if you don't want this information for labor units, Chris, you use them all the time. You can use the past jobs for what? The keyword analysis. It's really nice to know the budgeted time for a job compared to the actual time. That gauge, that percentage, guys, makes it interesting. Take this. If I budgeted for a job 3,000 hours, and actual time, man hour or worker hour time, end up being 2,890 hours. So I was lower than my budget. I can use this factor. I keep track of it. I can use this factor, which is, if you take the 2,890 divided by 3,000, and that will get you a factor, right? I can take this factor. Anybody can do that? What's the percentage of that one? So I have 2,890 divided by 3,123 equal, I have 96%. So 96% or so, 96%. My factor, there's a 4%. Now there's a 4% I saved. 4% of labor I saved. Guess what? What I could use with this 4%? I could go lower my overall labor hours on the coming bid so I can get the job. So keeping track of your labor, guys, get you a lot of information that you can use. Any questions, any comments? Zach, my friend, Ashley, where are the project managers? Do I have project managers and estimators here, guys, or more or less? If you work for an engineering firm and you would like to continue working as a designer, guys, that's probably FYI only. Variable that impact the labor unit, take this. A lot of things can impact, so can be applied to the job, must increase or decrease the labor units. These factors can make the labor unit goes up or goes down, and we're going to look at them. Some of them you can control it, others you can't. You have to accommodate it. And here's a few of these. When you adjust your labor unit, there are 2 ways of adjusting your labor unit. And the easiest way is to adjust the overall labor unit. Take this. I counted 1,000 hours, man-hour, to do this job. Because the job is hard, security enabling and disabling is needed, and all these, it's harsh, it's Minnesota, cold weather, stories and all this stuff. I have a factor in my mind. I said, you know what, because of all of these, based on all these factors, based on my judgment, I'm going to up that baby by 1.2. So I'm going to up it 2%, 20% because of the circumstances, the total. So that will give me then 1,200. So you throw another $200 because of the conditions, the total. That's one way of doing it. That's the easiest way. The other way, guys, is to go down to the equipment. So if I have an equipment, here's my receptacle. Back to my receptacle. I have a receptacle. It takes to install it 0.3 hours. Because that receptacle is in a hard location, need access, cold weather, you name it, I'm going to go up that labor unit by 1.1, 10%. Up directly to the labor unit. You can go down to the labor unit, or you can up the total. The easiest way is to up the total. Make sense? No? Tell my friend Jackson, does it make sense? So following is, this is the things that you have to keep in mind if you need to update to up the labor unit or not. Building condition. Do you need access to the building? Is the building heated, non-heated? A lot of these things. Change orders. Do you have change orders in the job? Concealed or exposed wiring. Construction schedule. So what are these, Phil, my friend? These are things to keep in your mind. Do I really want to go overall and adjust 10%, 5% or not? Job factors. Off hours, occupied premises. You can't work on certain hours. Overtime. Are you working overtime? You need to accommodate for that one. Remodeled old homes and repetitive factors. All these, in your book, guys, it goes into details and into how each one of these factors affect building condition, elevators, heights, and so forth. Wiring the entire building. Okay, so we have change orders. If you need change orders, there's a few things I want to highlight from the book, guys. Okay, so the height. Take this in page 36 in your book, page 36. If it's 1 to 2 floor, you don't increase your labor unit by nothing, 0. If you go 3 to 6 floors, you have to increase. If you're working on 3 to 6 floor, you have to increase it by 1%. And I'm reading from the top upper left corner of page 36. If you have 20 to 30 floors in the building, you have to increase every labor unit, guys, that you install there by 13%. That give you an idea, because it becomes hard to get into these buildings. Okay, so that's one. Let me look at another one, labor skills. So that's repetitive jobs. I want to look at the repetitive jobs. If you guys, okay, if you go to page 39 in the book that you guys have in the upper left corner, number 13, repetitive jobs. If I am building homes for a developer and I build 1 to 2 homes, you don't increase or decrease. But look at that. If I have 3 to 5 repeating things, I can reduce my labor unit by 15%. Who cares by reducing them? You can get the job. The ultimate solution is to get the job. If I am doing the same thing over and over and over 16 times or more, I become proficient in doing it. I can cut my labor by almost half. Do you see that, Elliot? Contracting, my friends, 45%. If I'm doing, take this, if I'm doing service, entrance, conductors, guys, we're changing service from 60 amp fuse into 100, and I've done tons of them, right? I can make, if it takes me $1,600 to change that one, I can cut it down to almost half of that, $800-900. I can do it. I'm proficient. I know how to do it. I do it fast. So who cares? If you can do it by half, you get the job. You get the job. So affecting, guys, when we adjust the labor unit, you can increase the labor unit, which is good. You can make money, but be very careful, though. You might not get the job. Or you can decrease the labor unit. If you decrease the labor unit, your chances of getting the job is high. But also, if you made a mistake, your chances of going belly up is high too. So these are a few things that can labor skills, the experience of the people who are working for you, ladders and scaffolds, um, and management style, material, shift work, teamwork, temperature, all these, weather, humidity, you guys go read them on your own. All these can affect one way or another your labor unit. For example, I want to pick one in page 39. In the middle left side of page 39. Shift work. If I have a single man who's single, Nick is single, and I'm married, so what's from a, we're both electrician working for the same company. If I want somebody to work third shift, which one do you think I should send? A married man or a single man, based on the increase?
What's the definition of shift here?
Oh, the shift.
Yeah,
Well,
not just the first shift being 8 to 5, it doesn't look like they are.
there's what is it? The 8 shift. I think they go from 8 to 5, and then from 5 or 6 to midnight, and after midnight to 7 or 8 o'clock.
I mean, they're saying that a married person wants to work third shift, which tells me that in this context, third shift is different than the day shift.
The first shift would be
When working in shifts, you need to take. I thought the first shift is the normal shift, normal 7 to 3:30. That's a shift for electricians, 7 to 3:30, 4 o'clock.
someone wants to work it.
So single, you don't increase your labor for single or married. If you go second shift, now you're getting into probably from 4 o'clock until midnight. That's the way I define second shift, or around that. You need, if you look at the, you have to, if you are a married man, you have children to go make supper, and your wife and your husband is yelling at you, you need to be there. So you have to, if you are making me work that particular shift, you need to increase my labor. That's based on that book, 30 up to 30%. The third shift, now third shift is at night. Kids are sleeping, I guess, and you don't have a whole lot of things to see. People are sleeping. You can go up to 20%. Anyway, and these are all suggestions, guys. You don't have to take them by any means. But what this helps you to understand is to manage your labor. And sometimes you really don't have control over whom to send there if they're not your employees. You make a call to the hall. They send you those electricians. You can't ask them if you're married or not married. That's, I don't think it's illegal.
Specific
I don't think-
employee, you just give them a number and that's it.
You ask for, yeah, you call the hall and say, I need 10 electricians. They go through the list, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, go. Now, if one of them is lousy like Chad and doesn't work hard, yes, I think the agreement is to pay him half a day or a day and then send him back to the hall. Can't remember if it's half a day or a day. And then ask for another one. They'll send you the number 11. That's the IBW agreement with Nika. Now, if you're working for C Electric, for like a company, if you work, you're hired direct. You know, you're hired and fired direct. Okay, so that's for this one, guys. Heat, cold, temperature, heat, cold, and so forth. Any question, guys, about this? And these, just please read them, especially if you guys want to be a project manager and estimators. Labor unit summary. A couple of things. Thought, estimate. So you have to develop your own. That's what we're saying. Okay, you should know the following. Do we guys know what the labor unit is now? Everybody knows what a labor unit is? Cool. Good. Labor unit is an hour or a percentage of an hour assigned to a piece of equipment. What's included and what's not included in the labor unit? We listed the 6 things that's included, from installation into supervision, into laying out and handling the material and cleaning and so forth. And what's including, like busting walls and holes and so forth. Standard labor unit have to be raised or lowered based on the condition. Feel free to agree or disagree with the percentages, but you agreed with the concept though. The harder the job, the more you have to do it. Which labor unit manual to use? The best one is the one that you develop. Most of the people use, if you're using shop, use IBW, Nika. You're going to look at them in a second here. And care about your competitors. It's not yours. Why don't you care about the other labor units? Not yours. You're not supervising them. They're not the same electrician like yours, especially for the merit shops. Develop your own labor unit over time. Adjust your labor unit to accommodate for the variables. And that will be chapter 3. Questions about the labor unit, guys? If you read the chapters, straightforward, right, Chris? You read it? Straightforward, not a whole lot of gimmicks. Before I leave this chapter, I want to walk you through a labor unit, NICA labor unit. Everybody got that one here, guys? So let's go just walk you quick through labor unit of NICA here. You get the NICA labor unit. This is a manual of labor units. That's exactly as good as it gets. 1120. Go over here. A couple of things I thought really interesting. If you look at this is it. This is how they do it in the NICA and IBW. Integrated Building System section. Scope of the labor unit, what covers material unloading, job site, scope of these labor units. See, okay, work operation, not included. Look at what's included here and what's not included. Now you can agree and disagree. This is another opinion of doing it. I'm going to read some of the not included, guys. Work operation not included in these labor units. Look at this. Supervision, programming, hangers, fasteners, installation, welding, painting, you name it. Application instruction. So these are gives you each one of them, guys. Integrated building system give you, and that's why, because I clicked on that one, give you what's included, what's not included. If you guys look at this, everybody, if you have it. If you have that one, you're going to go, let's go to something that you guys are all familiar with. Let's go to devices, will you? If you go to devices, here's your labor unit. I need receptacles, GFCI. You guys familiar with GFCI? Look at this, take this. It will take me, if I have a 15 amp 3-way receptacle, it will take me 35 normal. Where's my, okay, am I seeing all these here? Way at the bottom. And difficult. Can you guess? Oh, here you go. Thank you. There you go. That's what I'm looking for. Perfect. Thank you, buddy. So look at this. If I have, this is how NICA does it. If I have a receptacle, am I looking at everything? I'm going to get the units too, right here. Just one example here. There you go. You guys will get it. Can you see the C's? Everybody can see the C? All right, let's go down here. Everybody see that it's C at the end, right? C is 100. Take this. Here's my receptacles. It will take me, let's take this GFCI. I have 20 amp GFCI, 30 hours to install them in a normal application, room like this. If it's a difficult 43, very difficult 52, and local 35. I think local us here. Where's the local? The local, I don't know where they define the local. So let's just say it was a normal application. Take the 35, multiply it by, how many of them do you have? Give me a number, Ashley. A number of receptacles. 50. Here's a 50 receptacle. Ashley will install this building. And remember the unit here was what? Right here, C. So you divide this by what? By 100. So 0 goes with 0. What's 35 times 5? 35 times 5 equal 17, that will give you 17.5 hours. I need 17.5 hours to install these receptacles. This is it. That's directly from NICA. This, guys, if you are if you work an electrical contractor, you know, if you're a NICA, National Electrical Manufacturers Association, in they and IBW are in bed, and they do all these together. So if you're union shop, you are following these for the most part. So if you're Parson Electric, Hunting, Egan, you guys are one, right? Elliot, you take these, and then it's up to you then as a contractor to use them, guys. But these are your reference point. Does that make sense? Here's one reference point for you. So if you take this, so I'm just gonna, and if you go through this manual, it's unreal. There is so many of them, thousands and thousands and thousands of equipment. What I like about this, Ashley, is it has a picture next to the equipment. Obviously, GFCI, we all know how a GFCI look like. But if you have a fire alarm system with 48 zones, how does it look like? How many zones do we have? Unreal. So it helps you a lot. Let's just go to cables and conduits. Cables and conduits. You click on cables and conduits. It tells you, Chris, the minute that you do it. Come on, buddy, Obel. Why is my computer slower than me? So that sheet, it will tell you what's included in these and what's not included based on the assumption for those guys. Froze on me. Okay, there you go. Okay, here's a conduit termination. Conduits and not included, supervision, conductor termination, and so forth. So you have to read this one for this section before you even start looking at it. Now, when you're done, let's go THHN, will ya? I have you guys sized 600. Chris, what was the size of your conductor? Was it 600 that you brought to the building, or 750? 700? Okay, I don't have 700. I'm going to use 750. So I have 750. Let's say it was the same normal application, 54. Can you guys see that? It's 54. 54. I'm going to do calculation for cables here. So 750 THHN or THWN. Can you guys see that? Either THHN and THWN. And I have, Ashley, can you see the multiplier is M, million, 1,000? They should have seen K, use K. Okay, so we know the multiplier. Let's take this, how we do the math. Very easy, very simple. For this particular cable to install it, I'm going to use this cable, this hours. I have 54 normal condition. Zach, how many feet you want to run of this 750? Give me a number, big number. 200 feet. Divide this by the unit for these, 45 hours for every 1,000 feet. So I need to divide this by what? 1,000. So 0 goes with 0, 0 goes with 0. 54, 108. That will give me 10.8 hours. Did I do the math right? Right? 54 times 2 is 108. Divide by 10, 10.8, right? It will take me 10 hours, 10.8 hours to install this at 750. Just pull it. And that's real. What you're looking at here is real. These are number used for normal. If it's difficult, look how Nika does it. Remember, instead of upping the hours and lowering them, they do it right here, guys. If it's difficult, they add 3 more hours on it. And if it's very difficult, look how many hours they add. 81 to 54 is how many hours? 6. So that will make it 60. That 21, 27 hours, no? 81 to 54, 27 hours if it's very difficult. They add on that unit. Did you guys get the message? Everybody get that? The software that we're going to be using next quarter for estimating is going to be using very similar units. They call them Nika 1, 2, and 3. 1 being the easiest, 3 being the hardest. That's exactly what you're looking at. This will be Nika 1, Nika 2, Nika 3. 1 being the easiest work, 3 being the hardest. When I say the hardest work means, guys, a lot of factors. Heat, cool, access denied. You need to coordinate the access. All these factors that we studied, they're going to be located right in here. I can't emphasize how nice, guys, this to go look at the manual. For estimating the project that we have, you guys are going to be using it as a guide. I want to show you also in the back of your book, Mike Holt's book, he has also a manual, a labor unit that you can use. I think there's close to 1,000 component. So, and way at the end, you can find it. So, for example, if I need, I have a conduit, I have a receptacle. Look at this. This is way in page 23 at the end. I have a receptacle, non-grounding receptacle, 15 amp, 120. It's 18 hours for every 100 of them. And nice thing about this, guys, the manual that we have in this book, it gives you the dollar value too. How much it's going to cost. It's telling me here, Ashley, that for a receptacle, 15 amp, 120, I need $52 for every 100 of them. $52 for every 100 of them. So that's easy. 52 multiplied by how many of them? Divide by 100. That will give you the total. And 18 hours for every 100 of them. So you take 18 multiplied how many of them you have, divide by 100. That will give you the total hours and the total dollars. Nika does not give you here the total dollars. The price is up to you. You have to load it from the manufacturers and the vendors. Any question, guys, about this? Any question? Here's what I suggest for you, especially those of you who are going to be estimators or project managers, guys. Roam around with this the Nika manual. Roam around, look at things, I was looking at it yesterday, interested in medium voltage. I'm interested in medium voltage, so I was looking. There's a lot of medium voltage, 15K and 25K and 35K. These are things that dear to my heart. Probably doesn't make a whole lot to you, but you'll find a lot of good stuff here. I want to bring to your attention, guys, a couple of things right in here too. If you have it, there's calculator here. You can do calculation. I don't know if you noticed that. If you have it, there's also conduit size. So if I have number 3 conductors, number 4 aught, I have 4 of them. It size the conduit directly for you. Speaking of what you, here's number 3. Here's 4 conductors. Number 4 aught. They give you 2-inch, and I believe they are defaulting to EMT. I believe it's defaulted to EMT. The default is EMT. Okay, so that's your calculator. Electrical formulas. They have a list of electrical formulas that you can calculate things in it. Here's a single phase and 3-phase direct current. You can find the horsepower, the voltage, the percentage, and it does the calculation for you. So that's another plus. Temperature effect. There's some temperature effect, guys, about the productivity. Look at the effect of temperature on productivity. You increase the temperature. Look at that, increasing the temperature. Look at that, journeyman. Look what the journeyman had. Went way up. I increased the temperature to 120. I'm burning those guys. Nobody's going to product. I thought that was really interesting. If the temperature is, let's just say, what is that, close to 100 or so, you cut the productivity for your journeyman by 54. Journeyman productivity loss 53. So I don't know how much they use it, but I thought it's really nice calculator. Based what the temperature on people, time productivity. I haven't used how many. Look at this. Let's take this 300,000 hours increase of base estimated labor per month of extended. So the longer the job goes, drags, the less the productivity becomes. People are tired, and so this is really nice calculator. Look at this. If I have 500-hour job, I need to increase. I have 40%, 40 hours of loss in labor productivity. Don't ask me. There's some calculations that they do here. So I thought that was really interesting to look at. Time productivity, unit conversion. That can convert from any unit to any unit that God created. If I want meters, to convert it to feet. Where's my feet? Here's feet. A meter is 0.33 of a foot, right? So that convert between things. I gave you one of these guys. Introduction, manual, PDF, exit. Okay. Table of contents here gives you a table of contents of the stuff that you have. And this manual, oh, by the way, if you want to print it, let me show you. It's a PDF. It's 447 pages. So it gives you a lot of stuff. So, anyway, so use this one as we go through, Phil, through the 2 projects that you do. I believe you have to buy them if you use them commercially. Okay. Any question, guys, about the labor unit? Have I convinced you how important the labor units are? Have we talked about dollars yet? The price of the material? We haven't talked about price of material at all. This labor unit that we have in Mike Holt's book has a price on it. That's what we're going to be using. You can adjust it at the end. The difference between the Nika and this one, guys, have Nika is, of course, very, it's a huge compared to this, but this one has a dollar value for receptacles and so forth. Okay. Any question? Frozen until it's, there you go. Okay, so and you feel free, guys, to look at different systems and hangers. Grounding. Look at that grounding. How much information you have about grounding? That it tells you what you need to know about grounding and so forth. Any question? Yeah, if you want a PDF file of that baby, if you go PDF, look how many pages? 441 pages. You're looking at 441 pages. Please don't print them here. A lot of pages. Okay. Any question about Nika unit labor manual that you guys have? You also have another labor unit manual. Everybody knows what a labor unit is? Fraction of an hour assigned to an equipment.
When you say they're not including fasteners and hangers, I mean, and so you're putting a conduit.
Then you have to take the hangers. You have to take the hangers separate.
Oh,
Yeah.
okay, so when you.
There's a place
price
where
the hanger, that's when the.
Yeah.
labor gets considered.
you labor them separately. Yeah. So you labor them separately. Obviously, you can't put a conduit without hangers, so you have to labor them separately. Labor them separately. Any question, guys? I do have to take 1/2 an hour, guys, to go over one more chapter. Easier, this one. Do you have energy? Cool? Yes, Chad? It's common sense, guys, not math or physics, right? Yeah? Cool? Okay. You guys are my friends. I don't know how much of friends you're going to be by the time we're done here. Okay. Take this. This is only 21 slides. So don't sweat it too hard. This is chapter 4, guys. Chapter 4 talk about the process, estimating process. Now we know what the labor unit is. We know what the labor unit is. We have a manual in the book, and we showed you Mika manual, and it's really straightforward. The rest is just pictures of equipment in different sizes. If you're not familiar with, the nice thing, what I like personally, what I like about these is, if you're not familiar with the standard sizes for fittings, it's really nice here to have a list of all the fittings that God created. If you're overwhelmed with the manuals, you're not alone. Estimating is a different science, guys. Knowing the material is a whole complete different animal. If you're not overwhelmed, you don't know what you're doing. It is overwhelming. When you become an estimator, when we bring people to talk about estimating, guys, it will take at least 5 to 6 years to create a good estimator who understand the material, understand the system, visualize it, and so forth. We're just scratching the surface here. We're just scratching the surface. And some of you, Nick, my friend, if you decided to work for Michelle Cool Erickson, you would never use these. We use estimating slightly different. We don't use labor units. They use the square foot values and means just to come up with a rough idea. This method is used by electrical contractor. Why? Because you need a detailed takeoff of the project so they can order them. First, get the job. Second, order the material. Third, manage the job, labor and material. So electrical engineers don't manage the job. They don't have a foreman and buy the material. It's a job of electrical contractor. Okay, estimating process. If you guys remember the estimating process, we said they're estimating and bidding. Do you guys, anybody remember the difference between estimating and bidding? Bidding.
Price.
Yes. Estimating how much it's going to cost you. Bidding is how much are you willing to sell it to me, which is the difference is what? The difference is going to be, bottom line is the profit. The profit is the difference between them. It's going to cost me $100 to build this system, and because you're my friend, I'm going to sell it to you for $100. So I'm making no profit, but I keep my electricians working though. Or I want to add 10% profit so I can go to Hawaii with my wife and my children, right? Okay, so a couple of things. This only talks about the estimating. Chapter 5, guys, which we'll hit tomorrow, talks about bidding. And then we're done. That's it. That's all, the whole process. Difference between estimating and bidding. Must be selective. Why do you have to be selective in the jobs you bid on? How to prepare the estimates. If you don't understand the blueprint, what would you do other than start dealing as an engineer? Estimating forms and worksheets. Phil was showing me some of the takeoff sheet that they have. If you do take off, when we start taking off without sheets, you go nuts. There's so much details with these projects. Okay, a couple of things. What takeoff is? What is takeoff? That's what we're going to be answering. What's the bill of material? Pricing and laboring. We have a term that says pricing and laboring. What's pricing and laboring? Cost and labor of hours job. So estimate. So here's your estimate is determining, when you do the estimate, you need two things, really, right here. Material cost and labor hours. That's what your estimate is of for a job. How many hours does it take you to do the job, and how much dollars do you need to spend to buy the material? Then when you assign a dollar value for the journeyman, that will convert the hours into dollars, right? And then we can add apples to apples. If you're going to be, Rob, my friend, an estimator, and you cannot visualize things in 3D, you're going to be a not so good estimator. You have to be able to mentally visualize the mechanical requirement and material required for the job. we look at with Revit now. We're looking at 3Ds, guys, but we're more and more working with 3Ds. But in the past, and we still look at 2D, you need to be able to see the third dimension as you estimate the project. With me, guys, when you take off this project coming this week and next week, you're going to be able to look at the third dimension, take the third dimension into account. Okay, estimating process. Take this, my friend. The first one. The first step of estimating, Ashley, is understanding the scope of work. Understanding what needs to be completed and what doesn't need to be completed. But how can you estimate a job if you don't know what's need to be done? Common sense within the contract price. What needs to be done? I'll tell you a little story, guys. I started working one time. I did work for a house. Really story. Wiring. So I walked in. My boss said, we built this house. We're remodeling it. So I start doing what I would like the house to be. Three-way switches everywhere. Everywhere. Three-way switch here. Three-way. It's beautiful. That's what I would like my house is. I almost got fired when the boss came. He said, Chad, we're bidding it to code. What does the code say? One switch, one light. We're not bidding it for the perfect installation. So you're gonna be very careful. When you do things, what's included in the contract price, what you're paid for. You don't only be jerk with the customer, but you really have to watch out, especially small jobs. What is part of the contract? If the customer wants you to add more, no problem, we'll do it for you, but for a price. Adding one receptacle, guys, in the 10 receptacle that the owner wants you to do, not a big deal. Adding another 4, it's a big deal. We need to kind of spice it up a little bit. We need a change order. What's need to be done? Number 2, counting and measuring symbols. Step number 2. Step number 2 is takeoff. That's what the takeoff is. That's where you start to take off. Take off is 2 words. Measuring, symbols, counting, measuring distances, and counting symbols. You're going to measure how many receptacles and measure how many, count how many receptacles, and measure the feeders and the branch circuits for them. Take this, determine then, after we understand, we do the takeoff, we want to group them all in one sheet and call it bill of material. That's what they call it, bill of material. Material required for pricing and laboring. Determine the material required for pricing and laboring, so we assign the labor for it. So have a bill of material. Then, after I have that bill of material, a bill of material is going to be a receptacle, guys, a switch, a light, and so forth. That's my bill of material. And how many of them? 5, 10, 15, right? Then I need to assign a price for them. Then you go here you start assigning a price for these. So for this one, I need a receptacle. I'm going to assign $1, and this one another $2, and the lights $10 each. And that's for price. Then material. This is for my price. Then labor. I'm going to assign a 0.5 hour, a 0.6, and a light, a 0.7, okay? And then for every 100 of these, and then you multiply them, 5 times 0.5 divided by 100, for example, and you get your labor, and you add the material, you multiply this by this, this by this, this by this, add them, will give you the total. So what's pricing? Assign a price to the equipment. What's laboring? Assign a dollar value to the equipment. Make sense? No? And then the last thing, extending and totaling. Extending and totaling is adding the labor hours and adding the material dollars. Common sense, huh? Extending and totaling. Extending and totaling. Okay. A couple of things, guys, that goes through before you do the job. Ask yourself, before you bid on the job, is this the best use of my skills and talents? For example, I'm a small CA electric. Can I go bid really in a hospital? We're a 2-man job. We're 4-man shop. Can I go bid in a hospital? Seriously? Do I want to waste the time taking off a hospital? So these are common sense. Be selective on the project they select for. Don't waste your time. This is what they're saying. Consider the job as a reasonable chance to make a profit margin. Every time you have a job, always give yourself a little bit of profit margin. In this market now, I don't know how much this is true. Before you bid the job, what does your gut tells your body? Can you do it? Can you finance the job? Can you get the job? Can you make profit out of the job? Do you have money to finance the job? These are, as a project manager, very common sense, guys, that you're going to be, can I get the job? Do I have experience in doing it? Do I have a margin of profit? Do I have enough money for the, 5% or 10% bond for that project even to get into it? Okay, understanding the scope of work. Here's what you need to do to understand the scope of work. Be sure that much of the information about, you know everything that you can about the project. Complete current set of blueprints. To understand the job, you need two words: blueprints and specification. If you bid a job without understanding and reading and fully understand the project, the blueprints and specification, if you don't understand them, you're doomed. Another thing is visit the job site. It's really a nice idea if you can to visit the job site to see how access to the job, if any, just to give you an idea where the job is going to be located. Job folder to contain all the bids. A job folder. You guys remember what we talked about estimator traits? An estimator have to be well organized. You're going to be managing multiple jobs. If you have papers all over your desk and you can't organize things, you're going to get lost. So have a folder. I worked for my mentor for a couple of years. He has a binders for every single job that we did. Binder for telecommunication, binders for vendors, binder and a folder for dealing with the customers. You have to organize yourself, guys. Folders, tons of folders. Contain the bid work paper, all the bid work paper. You're working on 3 projects at the same time. The last thing you want to do is mix all these papers and come the bid opening and you're doomed. Organization skills. Estimate record worksheet. I want you guys to go with me. Estimate work sheet and look at one that we have in the book, chapter estimate and bid note page worksheet. Can you guys go to page 59, please? If you go to page 59, this is the estimate worksheet, record worksheet that you have to have. Page 49. Page 49, not 59, 49, cool. If you guys look at the 49, it tells you estimate record worksheet, job information, the job name, location, owner, bid due date, important, city, phone, plans and specification details, date of the plans, blueprint number, comments if any, jerk engineer for example, contractor information details, the contractor, the address. Look at the complete information about the contractor, important contacts, the architect, the engineers, the utilities, the inspector, and a couple of notes for you. Common sense. Every project, before you start taking out fill, my friend, you have to fill a page like this, right? Common sense, right? Get all the information in one piece of paper before you do the takeoff. Okay. Get deeper, quiet place, and read the specification. Before you get into it, make sure you read the specification and the blueprints, will ya? Read in a quiet place where you can't be interrupted. Keep a notepad handy so you can keep track of the questions you have. Estimate bid. Any question that you have and anything understanding, get the answer as soon as you can. Here's a checklist that you need to, before we do the checklist, I want you guys to go to page 51. Can you guys go to 51? There's a sheet there. When you're going through the specifications in page 51, when you're going through the specifications, you're going to ask yourself all the questions that you don't have, you're going to write them on one piece of paper. For example, estimate and bid notes, page 1 of how many? Blueprints, questions, or comments. When you go through the blueprints, you have things that you need, any question, write it down all together. And then the specification questions. Then you pick up the phone, call Michelle Cooley Erickson, and call Nick, is the engineer on the project, and say, Nick, could you please qualify 1, 2, 3, 4, 5 about the specs and the blueprints? You look like you're a professional. The best way of using your time, instead of every time you read something, pick up the phone and call Nick. Next, the first time, second time, third time, the fourth time, I bet you he's not in the office. You don't want to disturb people. So summarize all your questions in one sheet. Call the engineers or the architect to get your answers. Make sense? No? Then check, specification checklist. There's another in the second page, guys. Checklist. Can you guys look at that checklist that we have right in here? This is in page 52. Check specification checklist. I want you. It's a long checklist. I'm going to read a few of them. Labor unit adjustment. Do I need to adjust the labor unit for any or any one or all of these following, right? So check. For example, do I have ladders and scaffolds? Yep, check. Then you have to make sure that you adjust for that one. Rob, my friend, this will decide if you're going to be using, remember that NICA 1, 2, 3? Based on this sheet, you have to decide if this will be a normal, standard work condition, difficult, or very difficult, based on these checks. And who's going to decide? You. You're going to look at them and tons of them are checked. Check, 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 check. Well, this is going to be difficult. You know what I mean? One of them is checked. Yeah, I can handle that one. All of them are checked. Maybe it's going to be very difficult. You know what I mean? Then you go to adding labor, additional labor for as-built, demolition, energize, and all this good stuff. Direct job costs, permits, and so forth. All the way, other conditions, conductors. So this sheet is going to help you adjust your labels. This sheet is going to help you adjust your labels. Any question, guys, about specification checklist? Any question? Okay, here's the stuff, and I'm not going to tell you plans. Be sure to have every page of the blueprint, specification. Specification are additional requirements. You have to have them. Visit the job site. Be sure to visit the job site. Preparing for the estimates with folders and so forth. Record plan specification, estimate bid and notes. All these specification checklist, specification checklist worksheet. All these guys are major things when it comes to understanding the scope of work. Get organized, get all the information, read the specification and the blueprints. Get ready to get all your answers. Have a checklist so you can, if you need to adjust your label. Any question about that? This is just understanding the scope of work. Questions about understanding the scope of work? Any question, my friends? Next one, take off. Step number 2. We understand, we know what we're doing. Now we're going to go take it off. Take off. What is take off? Quickly and accurately estimate the job. Must have forms. I know, Phil, you were showing me the forms that you do with the takeoff. Count all the receptacles, everything, highlight them. So worksheets save all your, create consistency when you do takeoff, guys. You have to have sheets. All the receptacles are here. Color code them. Put them on a sheet. Form and worksheet also help to keep you easy to, if you've forgotten something. Okay, takeoff. This is my favorite. What is a takeoff? Counting and measuring symbols and components. This is my also second favorite. Look at this. When you count the components on the blueprints and you measure the distances for the feeders, the branch circuits, and the service, you should not need to refer. You should not need to refer back to the specification and the drawing. You're done. That's what the takeoff is. When you're done with it, you shouldn't need to go back into the specification. You have all what you want in multiple sheets right in front of you, completely color-coded, and you don't have to go back to your specifications. Unless you made a mistake, I guess. To do this, to make sure you guys have done it, you make sure you've done it right. Look what you need to do. And ask yourself, am I this person? You have to have an orderly, organized, methodical routine. A lot of people hate the routine. That is complete and consistent. That complete and consistent from each job to another. Complete and consistent. You cannot spin on a dime every time. You can't switch gears, guys. One time I'm going to take it off this way. Another time the other way. You have to standardize your method. Orderly, organized, methodical, routine. Routine is a big deal. Routine. Why routine is important, Rob? It cuts into your mistakes. If you have a routine way of doing things, it cuts in your mistakes all the time. If you're using green for receptacles, for example, every time, on every project that I take off, every time I see a green, what is green? Receptacles. If you use green and red one time, you're confused. So routine makes consistency. Consistency makes less mistake. Okay, color pencil. You need to, when you guys take off this week and next week, I'm going to give you colored pencils. You're going to be taking off with colored pencils. Colored pencil or pens to identify each item. Each item has to be color coded that you have taken off. Check. So I'm going to have a receptacle. I'm going to have a switch. I'm going to have a light. I'm going to have a cable. So all these color coding color coding of the equipment they're going to be using. Color coding. When you're done with the blueprints, your blueprint has to be colored representation of the equipment. So you have to have all the colors all over when you're done. And if you guys have seen some of the specification, it's busy. It's a lot of colors in it. A lot of colors. Lots of colors. Counting symbols. Identify the quantity so that you can determine the job material. How many receptacles? How many switches? Different type of receptacles and switches. Measuring circuits. So we counted, right? Here's one receptacle, two receptacles, one switch. Here's another type of three-way switches. We counted, this is GFCI. We counted them, right? And then here's a branch circuit. I'm going to wire this one from here to here. You need to measure this distance, 10 feet. To measure the distance, guys, so measuring the length of the branch circuit feeder services for raceways, the first thing you need to do is what? Look at this. Scale. The worst thing that could happen to you is you're using 1/8 of a scale, and the scale in reality has been shrunk or copied, and it's 1/16 now. So everything is going to be cut. Or you can go higher or lower in the scale. So it screws up your measurement. The first thing you need to do is look at the scale and verify if the scale is right. How can I verify a scale, guys? You go to a piece of equipment that's typical, a door in residential, 3 feet, right? Typical. Go measure it with your scale or with your wheel. If it shows 3 feet, well, that's a good idea. Something that has been sit there and has a dimension on it, and also to scale. So this piece of equipment, it says 3 feet on it, and it's also to scale. Measure it. Does it say 3 feet? Yep, the scale is good. Any question, guys, about especially when you measure, you have to pay a lot of attention to the scale. A lot of attention to the scale. Any question? Lots of attention to the scale. Sequence. When you do the takeoff, guys, you have to find some type of a sequence of doing takeoff. It doesn't matter which sequence. At least you start with lights, end up with switch gear or whatever. You have to start up with a sequence. Okay, here's one sequence. Sequence is how are you going to be doing it? Takeoff sequence. One section, page at a time. That makes sense. Start service, end up with lighting. Start at the service, end up with lighting. Start with lighting and end up with the service. Takeoff of sequence generally follows. Here's what you're going to do. So these are 3 different takeoffs. One page at a time. Start with service, end with light, or vice versa. Here's what I want you guys to wake up here. Counting, I'm going to start by counting my fixture. This is one. So step number 1, I'm going to be counting my fixtures and develop quantities for fixtures. Why do you think I count my fixtures? I need to, because fixtures, we do quotes for them. We don't take them off. We do a quotation for them. The second thing, when I'm done with my fixture, 1, 2, 3, 4, 5 for every time, I'm going to go count my switches. Okay, go to switches. That's the method that we're going to use in this project. Second thing is count receptacles. Third thing, measure branch circuits. Count and measure individual branch circuits, the home run. Then count and measure low voltage, television, Cat 5, alarm, security, and so forth. Count panels and the switch gear. The last thing is a switch gear. So this is the method that I would like you guys to use, at least in this project. So we're going to use 1, 2, 3, 4, 5, 6. That's how we're going to do it, guys. Starting with the fixture, end up with the switch gear. 6, 7. 7 here. The sheet, the Excel sheet that I give you guys to do the takeoff, it's going to be following this sequence. Following this sequence. Is it the only way of doing business? No. Okay, determine the bill of material. This is piece of cake now. When you determine the bill of material, guys, you put all this stuff in one sheet. That will be your bill of material. Enough information. The bill of material, so-called bill of material, not bill of rights, should provide enough information to determine the type. Look what you're going to have. The size and the quantity. The type, the size, and the quantity. Type, size, quantity. For example, and material item is required for installation. So I have GFCI, 20 amps is the type. The number is 33 of them. That's a bill of material. GFCI, 20 amp, and also 120 volt, the type, and the size, GFCI, receptacle, 20 amp, 120, 33 of them. Is that enough to get me a bill of material? Go buy them? No problem, Chad. Now assign a labor to this, and off it goes. That's your bill of material. If you have a computer, which we're going to be using next time, guys, that bill of material, the minute that you take off and you put them in the software, it spits the bill of material for you. It's really nice. You don't have to write them down. The sheet that I give you, Chris, it's actually going to carry that bill of material in an Excel format. Okay, spreadsheets. So we have bill of material. If you guys look at the fixture takeoff in page 53, they have a fixture takeoff, guys, and it says the fixture, the switches, and receptacle. Just count them. If you go to, let's go all the way to the bill of material that we have. Okay, in page 57, could you please look at page 57? In page 57, we have the bill of material that we have in this book. We have lay-in fixtures, ceiling fixtures, with the boxes and the rings, and how many of them do we have, right? So that's my bill of material. Moving on now, the next step, step number 4, I have a bill of material, Nick. I need to assign labor and price for it. I need to labor it and price it. So you need to have bill of material, items, you need to price it and labor it. You need to find the price from the, so pricing and laboring is finding the price from catalogs and the labor unit from labor sheets, from the labor sheets. Again, I have how many receptacle? GFCI receptacle 12240. How many labor? 0.5 hour for each one of them. And how much each one of them will cost? $12. So what's laboring, pricing and laboring? Assign a labor and a price for all the items that you have taken off. Materials and penciling these into the labor. If you have a computer software, what does a computer does? That's a nice thing about it. Runs the numbers for you. So do you have to do that? No. With your friend Chad, it's halfway through. We give you a sheet that has the pricing and labor in it. You can massage it in an Excel sheet. But we don't want to go copy things and make an exercise. If you guys look at please, if you guys look at page 60, pricing and laboring sheet 1 of 4. Can you guys page 60, 61? There are 2 pages. Can you guys see how they assign a cost? Like, for example, box 4x4 Mitchell, $59 for every 100 of them, C. And the labor is $18 for C. What's the C? Every 100. These sheets are called pricing and laboring. Cool? Everybody's okay with pricing and laboring? That's the method, Jackson, my friend, that you will be using. That's the method they're going to be using for taking off this project, step by step. Okay, so we went into pricing and laboring. The last thing is extension and totaling, guys. Extending and totaling is doing the math. So do me a favor, will you? Look at page 61, the bottom of page 61, right here. Can you see 1,825 and 94 cents? Adding all the dollars, that will get you the totaling. Extension and totaling in 81 hours. That's the totals, right? What's the extension? When you multiply them, it will give you extending and totaling. So labor hours, let me just get one very simple example. A receptacle and a switch. Receptacle and a switch. How many of them do I have? I have 30 of this, 15 of this. That's their number of them. What's the price for each one of them? The price is for the receptacle is $1, and for the switch is $2. What's the labor for it? The labor for this baby is, let's say, 0.3 hour, and the labor for this one is, let's just say, 0.1 hour. And what's the unit? The unit is CC. Done. No, actually, the unit for these are each. This one is E. This one is E. E for, let's do E here, E and E for the price and C for the labor. How about that? C for the labor. Okay, how do you extend this? How do you extend this? So let's extend this one, guys, right here, the price. So you're going to take 30 of them, extend them, multiplied by 0.3, right? Divide by 100. That's extending this. Let's extend this one. You're going to have 15 of this, multiplied by 0.1, divide by what? 100. So that's for the labor. Let's extend the material, the dollars value. So when you extend these, I'm going to use, you multiply these and you divide them by what? 1. Multiply these, divide them by 1. 1. Make sense? 30 times 1 divided by 1, 15 times 2 divided by 1. Why 1? Because it's each. This is called extension. And then when you add them up, I'm going to say plus, and you put the answer here. That's your total. Add them up, plus, put the answer here. That's your total. Answer. Does that make sense? Pricing and laboring. This is totaling, extending and totaling. If you have a computer, do you have to do that by hand or an Excel sheet? No. The Excel sheet that we have, guys, it's going to do all this stuff for you. The Excel sheet that we have is going to do all this stuff for you. Any question? That's it. That's what this chapter is all about. Estimate, the estimating process. Estimating process. Okay, so we difference between estimating and bidding is what? Profit. You must be selective on the jobs you bid. Don't waste your time on things that you can't do. How to prepare for the estimates? You have to have a place by getting a nice place to sit and read the specification and the blueprints. What to do if you don't understand the blueprint and specification? Go to the bar, drink, and get mad? No, you have to write them down and call for answers from the authority having jurisdiction, engineers, owners, manufacturers, whatever. Estimating forms and worksheet must have if you're going to be an estimator. Takeoff. What's a takeoff? Counting components and measuring distances for feeders and branch circuits. How to determine the bill of material. Add all the stuff that you took off in a sheet and call it a bill of material. How to price material, determining labor. So you go to the labor units, assign a labor unit, and price a priced unit, right? And then you do the takeoff for all of them. Any question, guys? Any question? Any question? So this is basically what we do. You guys have done half of the estimation right now in this chapter. Half of the process of estimating is done, which is the estimate. I want to remind you before I let you guys go with the homework, let you go eat. I'm going to remind you that there's some nice pictures in the book. For example, if you guys look at page 58, there is it gives you the detail, like detail 2. It's actually surface mounted lighting outlet suspended ceiling. Detail 1 is fluorescent lane fixture. Detail 4, exit light. You get all these pictures, nice pictures, because it wants you to visualize the takeoff process. Typically, if you are a good estimator, all these you visualize how it's going to be put together. Okay, can you guys see that? 1A and 1B. That will help you visualize. Look at the detail. Detail number 6. It says switch to gang. I have a box and 2 switches and a cover for 2 gang box. Make sense? Does it make sense? Yes? No? So make sure you know that. And the last thing before I let you do that one, guys, we're going to review the process of estimating. The process of estimating. Anybody can repeat that after your friend Chad? What's the process of estimating? Understanding the scope of work, right? What's next after we understand the scope of work? Take off. Take off. This is guaranteed on the final on the test, guys. Understanding the scope of work. Then you're going to do take off. Then pricing and laboring. You have to add the price and the labor to the material. Pricing and laboring. The scope of work. Take off. Determine the bill of material. Then pricing and laboring. then extending and totaling, doing the math, and the last thing you're going to find is an estimate summary. The estimate summary is going to find how many hours you need to do the job and how many dollars do you need to buy the material for the job. We're not done yet. Hours to do the job, material to do the job. Chapter 5, which I'm going to hit tomorrow, guys, will take it to the next level. Take it and add profit to it, and we do an estimation. Chapter number 5 will talk about that bidding process. And then chapter number 6, believe it or not, take off a house. It's chapter number 6 is nothing but applying 4 and 5. So if you want to pay attention, if you want to be a project manager, really chapter 4 and 5 is the whole estimating process. 4, do the estimation. 5 will build on it, build on profit and overhead, and do the bid proposal. Any question? I pushed you this time, huh? Okay, thank you. That's all I have. The book is so easy, guys, to read, straightforward.